Welcome back, guys. So let's get started where we left off on Wednesday. So we're trying to get the extend passing working. We had some header magic bytes issues. We fixed that, and we were able to go through all the entries after that, as in the initial directories under root, and then we were able to recursively get into one of the directory within that root. It was working, and before that the issue was that we were not a when we recursively went inside a directory, we got an magic byte error. We fixed that. It was just offset calculation error. We fixed that. And then when we tried to run it fully, we had nothing much. After that, things just went fine. And we just went through the overall flow and explained how things run. And we uncommented the actual parsing of those. And then we got a different error. That's why we left off last week on Wednesday. So let's just get started. Quick overview of what we are doing. Still working on our kernel. We have a new scheduler, user space, things like that. We are working on our virtual file system layer, and we have a X4 front end. We have already finished the VHIO backend for this. So yeah, let's just get started. My screen is visible. Okay, it's good. So now let's just run it. So let's uncomment this line. And now run it. Let's run it. And as you can see, we were able to parse every directory. So initially we just we have the raw bytes. We go through every directory and we print it, and then we go through every directory recursively, and we were able to print the actual inode of the directory. In this case it's 13, and we go inside that and check what sort of file it is, and I guess that's this one, this mode of the directory and mode of directory. And in case if it's 6384, which is X 1000, I guess, then it is a valid directory, so we should be able to go inside it and check if it actually has a proper inode magic bytes and stuff like that. So things all work, and we were able to do it for all the directories, and totally we passed 8 directories. So that was good. So that is just up to here. So we are just recursively parsing every directory. Once we have the actual directory, what output is just an inode, and we have the fields within that inode. But what we are missing is that once we have the inode on the inode block, we need to further parse them into directory extents. That is this code. So I'm gonna uncomment that and let me run it. Let's see what happens. So we know where we are. Okay, so it's done. So looks like we were inside 11, I suppose. Yeah, we were inside 11, and then we checked the bytes, and then we got the physical number of that inode 11, and the block is 8482. We read that, and the actual directories within that is dot and dot dot. That's it. There's nothing else. And we move past next directory. Next directory was 13, and the actual physical block was 8192, I think. And then we tried to do the same thing. We got the block, stuff like that. But finally, for some reason, once we have this physical block number, which is 8615, we got some, which we got an error from which IO. So it's somewhere down the line. So that's the issue that we are gonna try to debug in the session. Okay, so let's get started. So I'm just gonna copy this entire thing. Hopefully I can go to that. If not, we'll have to reduce some logs to keep it. So let's just, holy fucking moly. That's just so fucking annoying. Sometimes my Chemex just does not work on keystrokes, I guess. It just did not capture my yank. Here I am yanking, pasting everything. What the fuck, man? It's not open. So let's try that. And one fucking yank is not open. It's a shitty. Maybe I should just. Okay, it did work. Okay, it did work. So let's just tell the story so it gets into a little bit of context on what's going on. So we were able to, so let's just say we were able to parse our directories within the root nodes, root inode. So we get the inode number. I guess we wrote this entire thing yesterday in the end. Let me see. Yeah. We were able to parse all directories, get the inode number, pass it to explore root tree recursive with the inode number. And we were able to cover the convert that inode number further into inode struct. Now we have the inode struct, and when we are accessing the, no, this is the old commands, not this. I wrote something yesterday, I'm pretty sure. Yeah, it's here. So we are here in root, we get this inode, we convert that into an inode struct, and we take the inode struct's iblock field, which is just raw bytes, parse it as extents, and we get block results. And every block result is just physical block. It just holds a physical block, and we get the block results and physical block containing, and we get the actual block within that inode. Now we further parse that physical block as directory entries, and now we get the extend directory entry struct out of it, which actually has the file name and inodes. Now that we have the initial inode and inode directories, we can further do it recursively. So let's say we have bin and etc. So now we can call recursively on bin. So this is again just going to do the same thing. It's going to convert the inode into inode struct. It's going to get the block field and convert it into block results. And once we have the block result, we have the physical block. Now we start converting the physical block into external inode, but we are getting blocked here. So let's see what happens there. Oh, fucking moly. do I sometimes more VI simply does not work. I don't know why. Okay, this is what we wrote in the end yesterday evening. I mean, yesterday in this session. So, yeah, let's get started. I believe it should find the issue, and then let's actually think about it and see what else is going wrong in our implementation. But overall, from my point of view, it just looks fine. Probably we just missed some other parsing. As you can see that now we are able to actually get the proper directory, confirm it is an actual directory, and only then look into it. Because right now, if it's not a directory, we don't look into it. This is one of the issue that we fixed previously. We were just checking into it, and what we have done so far is just we added this mm, extra syntax to see if we are not gonna if we haven't found an actual directory, we just return 0. So it's just gonna return 0. Even the recursive function, the base condition also is gonna return 0, and there's gonna be nothing after that. So that's the baseline here. So our example, if it runs fine, we are supposed to get all the directories recursively. No matter which depth it is, we are gonna get that working. So yeah, while that runs, maybe we could also try to see what could have gone wrong. Let's kill it. And let's run it again. Okay. So we are in this. Probably it is coming from Kemu and not our egg. Yeah, it's definitely not our issue. So maybe what we can do is we can maybe try and see if our Kemu logs have anything about it. So let's kill it. Let's run it again. Maybe this time we could actually see that in the logs. Let's put Kemu. Okay, we have the log. It does nothing. Okay, fine. Looks like it does not have any other logs, so let's do one thing. Let's go back to our bash build, and we can just enable. Okay, so we have completely disabled everything. Probably that's why we don't see any. Currently, we're just going to trace every which IO logs. So let's do that once again. Let's kill it. Run it. Oh, we should be having something in our logs. Okay, that's better. So in the end, what happened is there are many requests. The final request is for sector 1. And probably we'll have to figure out what went here. I don't remember the exact codes that it would return because I haven't been debugging my block layer in a while. Okay, audio is too low. What is that? I am using my headphones because it's just too loud here in India. So I'm not able to just keep it as it was back in Stockholm. So I have to use my headphones, but I think my audio is fine. I'm not sure. Well, I'll double check my stream today and see if my audio is any better or not. Thank you for that. I'll double check maybe later today. Yeah, but overall, yeah, we still have to take a look at the virtual logs. Let's see if this has found anything. So yeah, as we said, something else broke, and which is probably our which IO layers. Let's pop to descriptor change. Try to read 16 bytes. What's the script rate? Now read the sector, so no bytes read. Process downstream times. Process finished. So root directory has 12 entries. Every what? A fake with zero. It's that because your image has metadata CSON Pichon runs exactly by accident, but correctly what means that 12 bytes is so it never confuses your game. I didn't fucking know that it is there, but I was thinking about looking back into whether there is something else that we need to parse, but so far everything works. Camelot hands out a whole page every time. Yeah, that's true. Ignore size of the allocation. It allocates text as a converts a bit in text to physical one upsets. Yeah, minimum one unit is 4 KB. Yes. There's no free. Okay. Looks like it's just our Camelot runs out of pages to give back. Yeah, looks like I even have a note about it because I know someday it's gonna come back to me because almost every allocation that I'm currently doing is a 4 KB page instead of the actual minimum amount that we actually need. So that's a big difference. Okay, looks like there's two possible ways to fix this. Either we have to fix our Camelot to make it work so that we will be able to allocate more pages, or something else is going on wrong with our Kmlock, maybe we can fix that. Or there's another way to fix it. I believe our um, which I is not supposed to use Kmlock, and it can just simply give out memory, something like that. I don't know. And it has found many other bugs, but how do we get into it? Should we figure out what went wrong with Kmlock, or should we figure out how to not use Kmlock inside Twitch.io, or should we fix things around Kmlock? That's the whole thing that we need to consider. Okay, I'm not particularly sure. Maybe we should think about fixing our Kmlock so that it only allocates proper amount of data whenever proper amount of pages instead of a 4 KB page. That could be a potential solution. That could be a potential solution. Okay, I'm not sure. So, mm, which of the allocations are genuinely long-lived? The which queue, the group array, and superblock. There's a scratch that dies at the end of the function, like request status and block buffers. And the first group belongs in the page group, no free. Also, one more thing is that we don't have a free. Everywhere we just allocate, we don't have anything to free. Literally, we don't have a free operation. Maybe we should just free up the things that we have allocated so far. Maybe that would solve it, but that would sidetrack us into maybe at least 1 or 2 weeks to actually write a working free for our case, because I believe if I introduce free now, most probably there's going to be lifetime issues, because if I just call free everywhere after I allocate, I'm not sure how long those objects are supposed to live. Right now it's always alive, that's why it's just walks. But when I bring in free into the play, we'll have to make sure that the object is not used anymore. So that's just gonna complicate things. So let's just keep Kmalloc as it is, and let's just try to fix it in which.io layer. So which are the allocators is fixed set of pre-allocated buffers. Second is lockless walk and unblocks you today. Okay, so what do we do? Do we wanna fix our which.io layer to use less of Kmalloc, or do we implement K-free and also a subpage allocator now, so that we can properly give out pages? I think I don't wanna get into K-free as subpage allocator as of now. It's just too much to work with. So I'm just gonna say that we're gonna fix a little bit of Okay, so let's just think about how and what to fix in our which IO so we don't use much Kernel, and let's just make that work. Don't try to import. Understand what's going on, what is needed. Yeah, okay, now let's see. I guess you should help me validate. I'm not sure, I still don't know why my audio is not good. I believe it should be fine. So I've been using this setup for a while now. So maybe maybe I was speaking in a low voice. I don't know. Where do pages actually go? So okay, when we do block read today, so let's go to our block read operation. Okay, so what do we have in our block reads? We have an array. Okay, so we already passed the array. We have a starting index, we have an ending index. We loop over it and we call sector reads. Okay, so sector read is the actual implementation. This is a wrapper. Okay, sector index calls. Okay, it prepares which I request, initializes it, and finds a free index because which is queue based, and we are supposed to you find a proper index and put the values there and notify it. So then in this table we allocate some memory, we pass the request, we set the free index, and finally finally we just notify which IO in that index, and then we just keep waiting for that index to come up in used object. Once it is there, we should be able to read it. Okay, so that's the general gist of it. So let's see what this gives. Okay, so request in sector read is of 16 bytes. Yeah. Oh, fuck. But we are giving it 4098 bytes, which is just a 4 KB page. So it's 8 sectors, 8 pages. Status in sector reads, it's 1 byte, but we are giving again a 4 KB page. Data buffer, which is of 496 bytes, and it's fine. So this is the only thing that is fine. The rest of it is not fine. Okay, maybe we can reduce this 64 KB of a page and to move 4 KB of data, and none of it comes back. As I said, we don't have a K-free, so we cannot reuse data. The request and status have explicit exactly the same lifetime as the descriptors that point to them. Descriptor 0 is only used while request 0 is in flight. Header and status byte are used for precisely the same window. Okay. Scripters and forget to pull things that they point to. That's the whole bug. Like the scripter, I didn't understand the bug. Okay, let's go further. One request per block, not 8. So sector read already takes a size and already does size. It's capable of multi-sector transfer right now. Block page just never asks one. Sector fields starting sector in vital bytes and data descriptor length is that transfer size. Any multiple of, okay, yeah, that is true because whatever we put here as size, yeah, must be of 512 because I remember adding something else and got some error. That's fine. So today we have 8 requests, possible 1 is descriptor consumed. I know about this too because right now I'm hard coding it to 512 somewhere because I'm always assuming we are gonna read 512. That's another issue. That I guess it's in block right, yeah. It's here. Read that. Yeah, I don't like this approach at all because it's trying to impose that we go with a constant pool and stuff like that, but that's not good. So we're not gonna do that. Okay, I guess I thought about this question. So it's this line here. So here I'm just trying to go through the loop. This while loop, it just waits for the last seen index to be equal to the index that is in which few object used. But it's keep on waiting. It's like a loop, and it's a blocking operation, but it doesn't have to be like that. the actual which IO specification suggests that we use interrupts and handle the interrupt. So once we make the once we notify it, we don't have to be here. We can just return from here and have an actual interrupt handler, and the interrupt handler should say that this particular thing or whatever it is ready to be used. That's the question here, I guess. Here the interrupt handler could just signal the completion for us, that specific read or write operation is done, instead of us just using a while loop and keep on waiting using a busy loop. I believe that's the question. Because also this helped me make the entire thing synchronous and lockable. Because right now I can just say I can hold this lock and wait here, and nobody else would be able to get into and do anything. But if I make it asynchronous, I won't be able to hold this lock here, because if I hold this lock and someone else gets into the same code, it's just a deadlock. So lots of things needs to be changed if I were to actually consider converting it into async and things like that. So I'm just not gonna consider any of this. I'm just gonna think about a better approach myself, because I don't think, I mean, most probably the suggestions it has made are valid ones and probably even better ones. But right now we have already made a lot of design choices and we cannot simply change things. I mean, if it's like really hurting our performance, yes, we can do that. And one of the issue currently it has suggested is that we are just simply allocating 4 KB pages every time we do even a small memory operation or small memory allocation, and we are not freeing it either. So that's a big deal, but still, I don't think it should matter a lot as of now, because we do still have a lot of memory. I think something else is going on. So I'm gonna try to think about it in that way. So even if there's 4 KB allocated for every operation, myself should be running out of discard all your materials and figure out what is the actual issue. Let's find a way to fix that first. So I believe we are supposed to think about it in that way, because I don't want to go around it and find some other solution, because right now this solution is not the best one, but it works and it should just work fine. And my heap is around 1 GB, I guess, so it's not really bad. And I'm not gonna see, this is why you should not believe stupid LLMs, because it will just hallucinate and say random things, and you'll have to actually think about it, because I know how my structure actually works, this entire setup. So I have something in my mind of this entire flow. So whenever it says something, I know whether it will actually integrated into my setup, and it suggested a lot of changes, and I know that those changes will not work because the moment it talked about why not have an interrupt, why do we have this while loop, I knew that it did not consider this global lock, and we have this entire global lock working on this case and stuff like that. So I know it's suggesting some things that are good, but it just does not see the bigger picture of this entire kernel. And right now, my image, the entire image sits inside my head, and I know how it should be. Okay, so is it my MMU? Okay, let it figure it out, and then we'll go through the entire chain and see if that's an issue. Because if it's in my MMU layer, then I guess it is worth fixing, because I'm not sure my L3 catch should be able to have enough pages. I'm not sure. Because right now it's suggesting that my L3 table failed some reason. Looks like it's in my L3 table. So let's go back to our tables. We didn't come here for a long time, and we're here again. So before, okay, so it already came up with something. Okay. The heap is around 512, but from what I remember, I thought I have 1 GB of tables, space tables ready to be used. That's how I remember it. I don't know, maybe I'll have to think about it again, but let's just read it, and then maybe we have a little bit of um, false facts. Maybe we have a little bit of good facts too. So yeah, let's go through it. Because it does find things that we are not able to comprehend, but then we'll have to assess it and come to a conclusion on our own. We should never agree with what it has to say, because most probably it's wrong. Okay, maybe it's in our L3 table, because looks like this this seems like a valid thing, because I know for sure my L3 entries are L2 entries are supposed to have 1 GB, and L3 entries are supposed to have just 2 MB. I think it is valid. Probably that we did run out of it, but I remember making it dynamic, and all my L3 entries are dynamically allocated, something like that. So let's read through it. An L3 table holds around 512 entries, and each entry is of a 64-bit descriptor. One table is 512 into 8, which is 4 nice bytes. Block 2 starts at the table for index maps from here. And we have L3. Okay, I didn't understand anything, but what I did understand is that we have some sort of limit for our L3 table and we have run past it. So I'm sure our overall pages should add up to 1 GB, but then probably my L3 table will finish at 2 MB and can only hold probably 512 bytes. I guess this is the issue. Here, maybe I believe that 512 into 10 should give me room for 10, but maybe instead of thinking about whatever it says, maybe I have to consider what is really here. I have to think about what exactly is it. Let's start that instead of assuming anything. Line number 620. Okay, let's read this. For every L2 index, we create a new table, L3 table. Okay, as I said, we have L2 tables. L2 tables are supposed to be for 1 GB index. So within that, we are going to have a L3 table, and L3 tables are going to have 2 MB per table. So we use the block plus 512 as the logic to find the index. Okay, even we have mentioned it here, like if we try to allocate more than 10 L3 tables, we'll get an error because we need to update it here. Okay, what the fuck should I update? Wait, let's think about it again. Map pageable entry. So what does that mean? It's like mapping a virtual address to a physical address. And we get the alone index of that VA. And if the L1 index is not 3, we are not able to go past it because L1 index is the one that I mentioned that it's going to be probably 1 GB. Wait, I'll have to recall this entire thing. Did I write it anywhere? Mm, no, I have no idea how much is my one L1 index can hold. How much? Wait, let's first of all think about it and then we can consider about fixing anything. I should have wrote this somewhere. And my L2 L3 index is actually dynamic. Probably the only thing I'm missing here is this 10. And if I probably increase this to 20, then probably I also increase this. Increase this to 20 here. Now just run it, let's see what happens. Okay, we still have the same house, so maybe we also have to update it somewhere else. Okay, let's back to recalling our L1 index theories. And so we have a 16 bit, so that is 48-bit VA. So we have 4 levels, that's L0 to L3. Each level consumes 9 bits. So my L0 is supposed to have 512 GB, so every index within this L0 is about 512 GB. So my L1 index is 1 GB. This is why I'm pretty sure that I have to write it down here. My L1 index should be 3 because we only have one table in L1 and it can hold up to 1 GB, and that is all our kernel is supposed to use. Okay, so this is my theory. That's why I just have, if the L1 index is not equal to 3, which is my actual entry, which is just one entry within L1. If it's not that, then probably I'm trying to access some other space which is beyond 1 GB. So I can just stop here because I don't want to use more than 1 GB. And then I can, this is just for one time purpose, leave that. And then we come to the second case. Here we are actually trying to allocate it. So The total will be the amount of pages we want to allocate. If we want one page of 2 MB size, it's like allocating 512 4 KB pages. Okay. This is also not dynamic yet because I believe my L2 table is still static. Yeah, only my L3 tables are dynamic because as you can see here, my L2 index has a base address which is static, and every L2 index is supposed to cover up to 2 MB, and which is just 1 GB, which is my one index in L1. So I just need one 2 MB of mm, memory which can hold up to 1 GB. So now I'm trying to take the L2 index, and then here I prepare the L3 table, which is just this arithmetic that I mentioned, which is just L2 uh, table into the index. So I can just go to whichever index I want to. So it should have worked because I increased the size here. I increased the size here to yeah, it exactly covers 1 GB. This is my entire thing that I can actually use. And I can have and I have one L2 table within that L1 index. So I have only one L1 index. Within that index, I just have one L2 table address, and that is of 2 MB, and that L2 table can hold up to 5 to 512 L3 tables, and each L3 table is of 2 MB size. So this is perfect. My code should be just fine. Now the actual question is that if I increase my 512 into 10 count to 512 20, that's what I mean. This now I should be, now that should be able to hold more L3 tables. Because it feels like that, because if the actual issue was that We are reading past some actual L3 table and we don't have anything. What the fuck? Okay, this is my logic, which is here. It's here. So L2 address plus 512 into index. So every 512 is the actual L3 table within my L2 index. Okay, so my logic is wrong then. So it should be 496 into L2 index. But that does not make any sense. So what it is trying to say is that I should change this 512 into 496. I don't understand. I should between 4096. We can only have 512 entries per table, and my L2 points to a table. That table holds that table can hold how many L2 entries? My L2 points to a table. Points to a table, and that table can hold up to 512 L3 tables. Each covers 4 KB. That was my mental image. So my mental image is like this. So I have one L1 entry that is going to, that's just 1 GB. So that is going to point to a L2 table. So now we have a L2 table address. So the L2 table can hold up to 512 entries of 2 MB size. So my every entry maybe I'm getting it wrong. There's only 512 entries per table. How big is one entry? Entry is 8 bytes, not 1. Why is that? Maybe that's the issue. Then how come the whole thing worked so far? Yeah, yes. So yeah, L2 table, he alone has a pointer to L2 table. That L2 table has 512 entries, and each entry is just has a pointer. So each pointer can hold the whole point to an L3 table. So we have only one L2 table. Within that, every entry is pointing to a L3 table. One L2 table is of 4 KB and 512 L3 tables to 2 MB. Okay. So this is the issue. 40, but I don't know how it worked so far then. Seems to be really odd. No, this is 512 because here it's just entries. But here I put 0, 6. Okay, it works. And we are able to even see directory entries. So we are even able to print the entries within certain directories. But that's just so fucking amazing. So let's again next week go through um, understand our L1, L2, and L3 entries again. Why did we change from 5 to 496 size? But it worked perfectly. Right now we are able to parse everything. So we started here, which is the initial directory. We printed everything. and we went inside the initial directory, that is just dot dot, and the second directory it didn't have anything, and the third directory has these many outputs, and we are able to even print those outputs properly, null, zero, full, random, and urandom pty. And then we got into the next directory, and it had these many files, and we were able to print everything. So the entire parsing is working recursively perfectly. And it's just amazing. And we were able to parse up to 256 directories, and I guess that's just the limit we added. So it should be fine. Okay, that's interesting. So tomorrow or next week, let's just again go through the our MMU and understand our L1, L2, L3 tables again. It looked like we made a mistake and somehow it worked so far, but today when we had this issue and when we actually had to move from 512 to 4096, things started working, which is just completely wrong. So I have to try to fully understand it again to see why it worked, because even now I don't understand why it worked, because it's just simply, it does not make sense from my understanding. Every table entry, every index within that table is supposed to have one entry, and that entry should be a pointer, and that pointer should be pointing to a table, and that's how I remember it. So that's why I used 512 as size, because it's just one entry. But somehow today it's saying that one entry is not 1 byte, it's supposed to be 8 bytes. That's why when we changed it to 4096, it worked. Okay, whatever. We'll work on it next week then. Thank you guys.